All right. So the picture here is of obviously Earth, and you can see the thin layer of atmosphere that's about 60 miles thick, and our diameter, the Earth's diameter, is actually about 8,000 miles thick. And so most of that atmosphere, the content of that atmosphere, is happening within the first 10 miles of the surface. And Shasta has a good analogy for that involving an apple. Do you want to share that?
Yeah, so if you were to think of the Earth as being an apple and the atmosphere as being its skin, this would be an apple whose skin is actually 100 times thinner than an actual apple's skin. So even an apple skin is 100 times thicker around the apple than the Earth's atmosphere is around the Earth. So it's a very, very, very thin boundary around our planet.
Right. Some people think of the atmosphere as being this boundless, endless, giant space, but we can actually have some impact on it. So it is composed primarily of nitrogen and oxygen. Only about 0.04% is the famous carbon dioxide that you hear about all the time, which is one of the primary greenhouse gases, and far less is methane and other sources of greenhouse gas emissions. So that's just sort of the composition. So what is climate change? Folks have probably heard about the greenhouse effect. Greenhouse effect is really important. The greenhouse effect is when the sunlight passes through the atmosphere and warms the Earth's surface. So it acts like a blanket. It naturally traps the heat into Earth, and that's what helps sustain life. So these greenhouses are a really important and good thing in the right balance. So what's happened in recent history is a change in the level of carbon dioxide and other emission levels versus what they have been historically, at least during human history. And so in the last 10,000 years, records show that before the Industrial Revolution in 1751, carbon dioxide levels in the air had risen by 10%, so over 10,000 years. Atmospheric concentrations of CO2 since pre-industrial times have increased more than 40%. So that's in the last couple of hundred years. And it went from 280 parts per million to over 400 parts per million. And in fact, there's news all the time that we're hitting new record highs of parts per million of carbon dioxide in the atmosphere, higher than it's been for 800,000 years. And so, like we said, there are some natural causes for some climate fluctuation, solar radiation, volcanic activity, but none of them correlate well enough to explain the rapid changes in our climate that we're experiencing. And so human activities, on the other hand, we know that we release about 30 billion tons of CO2 in the atmosphere every year. A lot of that's through fossil fuel combustion, which accumulates over time. So we have like what some refer to as a carbon bank, and so it sort of accumulates. It doesn't necessarily dissipate or go away, so it's accumulating over time. And that's the impacts of that are exaggerated by our continued deforestation. Forest would be a natural sequester or something that would absorb the concentration of CO2 back out of the environment. And so there's all sorts of ways to look at evidence for climate change. I really enjoy using NASA because everybody knows NASA, and NASA has a great website where they are showing all sorts of metrics for how we know climate is changing. And so they look at, primarily the big indicators, global average temperature rise. And so like we said, July was a historical record. The second below that, basically the highest 5 Julys have been in the last around 10 years. We have seen a 1 degree Celsius increase in global temperature since pre-industrial times, and that is exaggerated further in the Arctic, where they're seeing 2 to 3 times higher. I think my little video here on the right might be playing, and this is just showing actually changes in sea ice extent over the years. And so you just see it's coming and going, but over time dwindling pretty significantly. Other indicators are warming oceans, rising sea level, shrinking ice sheets, declining Arctic sea ice, glacial retreat, an increase in trends of extreme events, ocean acidification, decreased snow cover. These are all things that scientists look at and are able to establish trends over time to see how things are changing. One other thing I did want to point you to was this page. So since we're going to be talking somewhat about the National Climate Assessment, and that's so supported by an organization called the United States Global Change Research Project. And if you ever need some really good statistics or some charts or just a place to send people on finding some data behind the metrics we talked about, this is a good place to go. So, you know, for example, if you want to just go in and look at, say, glacier mass balance, it gives you a nice little summary and some key statistics about what's changed over time. And so it's a good resource to go to if you're looking to establish, if you're looking to establish the case for climate change is happening.